In the world of AI, there's always been this fundamental trade-off. You could have a model that's incredibly powerful or one that's incredibly fast. But getting both, that's been the holy grail. Well, today we're diving into a new technical paper from Nvidia, because with their model, Nemotron 3 Super, they're claiming to have done just that. And this right here, this is the core promise. Just look at this chart. On the left, you've got accuracy, and on the right, you have speed, or what we call throughput. Now, see the green bars for Nemotron 3 Super? On all these different tests, it's right up there with the competition, neck and neck on accuracy. But then your eyes drift over to the far right, to the throughput. It's not just a bit faster, it's way faster. And that's really the whole story of this model, top-tier smarts at an absolutely blistering speed. So what is this thing, really? Well, Nemotron 3 Super is a massive 120 billion parameter model. But here's the magic trick. It's what's known as a mixture-of-experts model, or MOE for short. I want you to think of it like a giant library with 120 expert librarians. For any question you ask, you don't talk to all of them. The system routes you to the 12 most relevant experts. So you get the knowledge of the entire library, but the speed of consulting with a much, much smaller team. Okay, so for this explainer, we're going to follow the complete how-it's-made journey of this model, pulling directly from the paper. First, we'll dig into the core idea. Then, we'll look at how Nvidia actually built the blueprint. After that, we'll see how they trained it to think and act. Then we'll cover how they optimized it for that crazy speed. And finally, we'll talk about why this model is such a big deal. All right, let's start at the beginning. What is the fundamental concept that makes this whole thing tick? What's the big idea here? The real innovation is this hybrid approach. They've essentially merged two cutting-edge AI architectures to get the best of both worlds. On one hand, you've got that mixture of experts design we just talked about, which is fantastic for packing in tons of knowledge and getting really high accuracy. And on the other hand, they've woven in a Mamba-Attention architecture. This is a newer design that combines Mamba, for processing things really fast, with attention for understanding deep, complex relationships. That combo is known for being super efficient. So by fusing them, they're shooting for maximum accuracy and maximum speed. Okay, so that's the idea. But how did they actually build it? This brings us to the pre-training phase. This is where the foundation is laid, where the engineers and scientists create the fundamental architecture of the model. The whole thing really stands on three key pillars. First, there's a brand new, more efficient MOE design they created called LatentMoE. Second is something called multi-token prediction. Now, this is a really clever trick. Instead of just guessing the very next word, the model can predict several words at once, which helps it generate responses way faster. And third is the specific pattern they used to weave those Mamba and attention layers together, hitting that perfect sweet spot between speed and reasoning power. And you can actually see that hybrid pattern right here in this diagram. It's not just a random mix. They very strategically interleave these super fast Mamba layers with the more powerful, but also more computationally heavy, attention and latent MOE layers. This specific structure, this layering, is really the secret sauce to its incredible performance. Let's just zoom in on that first pillar for a second. LatentMoE. This is one of Nvidia's big innovations in the paper. It's their own special flavor of the mixture of experts idea that's just better. It squeezes more accuracy out of every single bit of computation you feed it. It's like they not only hired a team of experts, but they also gave them a super efficient system for routing problems to the right person. Now, to build a brain this smart, you need data. An unbelievable amount of data. Nemotron 3 Super was pre-trained on an astronomical 25 trillion tokens of text. To put that in perspective, that's like reading the entire English Wikipedia thousands and thousands of times over. And what's really crucial here is they did this whole thing using a super efficient, low-precision number format called NVFP4, which saved an immense amount of time and energy. So, once the basic model is built, it's kind of like a brilliant brain with no real-world skills. The next phase, post-training, is where it basically goes to school to learn how to reason, how to use tools, and how to perform complex, multi-step tasks. And this schooling happens in a few key stages. First up is supervised fine-tuning. You can think of that as learning from high-quality textbooks. Then comes the really advanced stuff, reinforcement learning. They put the model in these virtual environments where it learns by doing, gets rewarded for correct answers, and even gets specialized training for really tough fields like software engineering. And finally, it's all aligned with human feedback to make sure it's helpful,
harmless, and does what we actually want it to do.
The whole point of all this training, the end goal, was to build what the paper calls agentic capabilities. And this is the real difference between a simple chatbot and a true digital assistant. It's the ability not just to talk about something, but to act on it, to use tools, to plan out a sequence of steps, and to actually solve problems, not just describe them.
Okay, so at this point, we have a powerful, highly educated model. But it's still way too big and slow for practical, everyday use. This brings us to the final step in its creation, optimization, through a process called quantization. Quantization is a really cool process. The simplest way to think about it is like data compression, but for an AI model's brain. It takes all the complicated, high-precision numbers that make up the model's intelligence and converts them into simpler, lower-precision versions. The result? A model that's dramatically smaller and runs much, much faster, all while losing an almost unnoticeable amount of accuracy. And this slide illustrates that trade-off perfectly. You can use high-precision formats to get the absolute highest accuracy, but your model will be slow and a memory hog. Or you can use these low-precision formats like NVFP4 to get incredible speed and a tiny memory footprint. The genius of Nvidia's work here is in the careful calibration, which let them get all the benefits of low precision with almost none of the drawbacks. So what's the final payoff for all this work? Let's circle right back to those performance numbers. After quantization, Nemotron 3 Super delivers more than double the throughput of one major competitor, and a mind-blowing 7.5 times the throughput of another. I mean, these are not small improvements. These are massive, game-changing leaps in efficiency. This brings us to our final question. Why should you care about this? Beyond all the impressive charts and technical jargon, what is the real impact of this research? So let's just recap the big takeaways. We've got a model that hits top-tier accuracy. It delivers a huge boost in speed. It's all built on a clever, new, efficient architecture. But honestly, the most important point might just be this last one. It's completely open-sourced. And they're not just, throwing the final model over the wall and calling it a day. Nvidia is releasing everything on Hugging Face, the model checkpoints, the post-training data, even those specialized agentic datasets. They are sharing both the ingredients and the complete recipe. This empowers the entire AI community to learn from it, to verify it, and to build on top of this breakthrough work. Look, this combination of raw power, incredible efficiency, and radical openness, it's a huge catalyst for innovation. It lowers the barrier to entry for developers and researchers everywhere to start experimenting with truly world-class AI. So the release of this model doesn't just end a research paper, it really starts a whole new chapter. And it leaves all of us with one final, exciting question to think about.